All right, so we have the atom. So the atom, in the atom, we have several different things. So the first thing we look at is subatomic. So if we look at two words, we have sub and let. All right, so for the atom, we have an atom. Kind of think of this is going to be some atom. We put it inside of a box, and then below the atom level, subatomic, we have other particles that we'll find as well. So the first thing I like to think about is the nucleus. So inside the nucleus, we have protons. They have a positive charge. We also have neutrons that are neutral, and this will kind of be inside of our nucleus. There wouldn't be a container for the nucleus, but the nucleus is just contained of where the protons and see a picture. So in this one, you can see that there's no ring around it. We just have protons and neutrons centrally located, and then we have electrons that are located in the orbitals or the region of space where we're likely to find an atom. All right. So we have our protons and neutrons inside the nucleus, and then out here we have our electrons. So electrons are located inside the orbitals. So nucleus, that's going to be our protons and our neutrons, and then orbitals. That's going to be our electrons. So we have our protons, neutrons in the nucleus. Electrons are outside in the orbitals. And if we think about the atom as a whole, our mass is going to come strictly from the nucleus. So the mass is going to be 2. Our protons plus our neutrons. So if we want to know the mass of this element here, we would simply look inside the nucleus and we would count the number of protons and add that to the number of neutrons, and that would give us our mass number. So here we can see we have a mass number of 7, and that's due to 4 neutrons here. The gray ones are our neutrons, and then the red ones are our protons here. The electrons are essentially like our hair. So Mr. Cantor weighs about 155 pounds. If I take one strand of hair off, I still weigh 155 pounds. So electrons are essentially massless. They're not really considered to have mass. Of course, they have mass because they exist, but it's so small, it's negligible. All right, so the mass is basically going to be our protons and neutrons, and then our electrons are outside, and then all right, so and then we have the identity of the atom. The identity of the atom is solely related to the number of protons. So the number of protons is essentially like his social security number. So this is how we identify the atom. So if I see an atom that has 3 protons, 1, 2, 3, that's going to be lithium. And so let's say, well, what if we added 2? Would that be lithium with 2 additional protons? No, it's like if I changed your social security number, that's for somebody else. That's different. So if we add 2 protons on, that's no longer lithium. Now it's boron. So if we look on the periodic table, boron has an atomic number of 5. And then now if we added another one, now we have carbon. Carbon has an atomic number of 6. So every time we change the number of protons, we change that atom's identity. We can also change the number of electrons. That'll change the charge on the element. So if we add an electron, that's going to give it a negative charge. This is like, because electrons have a negative charge, when you take it on, you become negative. It's the opposite of math. So if I take away an electron, that's not negative like math. If we take away, it's negative. In this case, if we take away an electron, now we have an imbalance of protons. So now I have 3 protons and 2 electrons. That's going to give me a charge of 1. So see, the charges, positive, negative cancel out, positive, negative cancel out, and I'm left with 1 single positive, and that would be the charge on it. So, and if we want to change the mass of an atom, we can change the number of neutrons. That makes an isotope. So isotopes are made by changing the mass and keeping the identity the same.